Welcome friends, in this one I'm going to show you how to find every derivative of a particular form. So take a look at some concrete examples followed by a rule. Based on the examples, then it makes more sense. So imagine we want to differentiate with respect to x, for example, say sine of 2x. 2x is the inside function and sine is the outside function. Alright, so sine is the outside, 2x inside, so differentiate the outside is going to give you a cosine. The inside gets copied unchanged, so it becomes 2x, right? But because 2x first takes x and multiplies by 2, it's a function. In other words, you got to multiply now by the derivative with respect to x of 2x this way, the inside function. Clean this up a little bit, so it's going to be here cosine of 2x times 2. And of course, by convention, the last thing that we do is we try to write this with the 2 out front, so it's going to be basically 2 cosine 2x. Now let me trace over something important here and relevant, right? Like this 2 right here that I'm tracing in pink, you see how it's also located now here? Okay, keep an eye on the next example. You'll see the pattern shortly enough. All right, so I'm going to write a little bit more here so I have more room. So the derivative with respect to x of sine of 3x. Look for a pattern. All right, so differentiate the outside, that's cosine. Copy the inside, 3x. Multiply by the derivative of the inside, so the derivative with respect to x of 3x. Then actually do the differentiation of the 3x, so it's going to be cosine of 3x multiplying 3. And then of course at the end, that 3 you can put all the way out, so it's going to be 3 cosine of 3x. So take a look, right? You see? This is a 3 and this is a 3. It's not an accident, it's there for that reason, right? So let's do one that involves pi, for example. So the derivative with respect to x of, say, sine of pi x, this way. Same principle applies. Remember, pi is just a number, that's all it is. So derivative of outside is cosine. Copy the inside unchanged, pi x. And then right next, the derivative with respect to x of the pi x part this way, which is the argument. What's within the parentheses is often called the argument. And then you go through that, so it's going to be cosine of pi x, let's see here, cosine of pi x, and then the derivative of this one, this is pi times 1x, right? So x gets differentiated away, pi remains, so you have a pi here. And of course, as in the previous two examples, the pi you can put out front, so it's going to be, let's see, pi cosine of pi x. I hope you see the pattern by now. So this is pi, and then there's a pi originally here, correct? There's a pi here and a pi here, a 3 here, a 3 here, a 2 here, a 2 here. So let's do the general rule. It's going to work like this. The derivative with respect to x of sine of ax. So now this a above is pi, above is 3, above is 2, but in general, we can just call it a. It just stands for a number. Having said that, you just go to the same process as in the previous example. So it's going to be the derivative of the outside. So cosine of ax. So differentiate the outside, copy the inside, ax unchanged. And then multiply by the derivative of the inside. So that would be the derivative of ax this way, whatever that happens to be. A, again, up here was pi, 3, 2, 1/2, negative 1/2, whatever, some number. And finish this up a little bit. So it's going to be here, let's see. Cosine of ax. When you differentiate the a and the x, remember it's a times x right here. So x gets differentiated away, and then a remains. Just like pi remained, like 3 and 2 and so on. So a remains, and then you write this in its final form. By convention, put the a out front, so a cosine ax, like this. So this is a cosine here. Let me stress, whatever you see in this position, right, whatever that a is, it now ends up being out front also. And then this is a way to do math, where what you do is you look at some specific examples, you try to find a pattern in the examples, then you try to generalize the pattern. That means usually, instead of having a specific value like pi, 3, or 2, you just put an a in there, a parameter. But then you go through exactly the same steps, you see? And that's it. Now you have a formula because it has a. So if a is 3, then it's this question. If a is pi, then it's this question. If a is 2, then it's the first question. And that's it. So please leave a like, please subscribe. Thank you so much for watching. I hope this has been helpful. I'll see you in another video.